Hello, here we are going to discuss about the doubly linked list. Okay. So, in case of single linked list, we have observed there is one head, this is like head, a variable, pointer variable which stores the first address, say for example, this is 7000. So, 7000 is stored here, here is value say for 20, another node, and like this way there are multiple nodes. So, these are different nodes of this list, like this is 9000, 9000 is stored here, say for example, value is 30, here 8000, here it is the base address 8000, say for example, value is 55 and it is storing 7000. 20, okay, whatever, this is 7020 and value is 45 and this is null. Now, by in this way what is happening, head is this variable is pointing this one, this is pointing this one, this is pointing this one, this is pointing this one. Now, whenever assume there are huge number of elements, 1 lakh elements, 2 lakhs elements, so there are more elements are there. Now, in this case the problem is that we are going to store the values in some place. Say for example, in an web browser there are different browsers. I am browsing this particular page, then this is my first page, and I am next browsing this particular page, this is our second page, next browsing this particular page, this is our third page. Now, if we try to go back, then the going forward is not easy for this case, and even we can't able to go that place. So, if I have this value 8000 value, if I am here, then I can move forward because I have the address of the next node, but I can't move backwards. So, to resolve this problem, we have another concept. This concept is called double linked list. The concept is very simple. Rather than having single value, we are going to store two different values. So, say for example, this node is going to store the address of the next node, at the same time this node is going to store the address of its previous node, that is 7000 it will store. This node not only store the next value or next address, it will store the previous value, that is 9000. So, by this way one link will be created from this to this. So, this node have some value, initially we have null, and this node having the previous value, that is 8000. So, by this way double link will be created, that is why it is called doubly linked list. There are different applications, huge number of applications are there in our operating system threads. This type of applications are also to keep track of their execution, we go for this type of data structures. Let us have a look how this type of this can be implemented. Okay. Now, here assuming, so what we are going to do, we are going to allocate some memory space which having three different places. One place is representing value, another place is representing left L address, and another place is representing a right address. This is left address, that means it will store the address of its previous node and it is going to store the address of its next node. Here is the value. So, we are trying to create this template. How we can able to create the template? So, we will write struct, say for example, I am providing D-link is the name for double linked list, and here we are allocating a variable like int val, and there will be two variables of same type, that is struct D-link pointer LA, this will represent left address, and this is pointer right address. Okay. So, by this way we will create the template for this. Now, we are trying to create initially what we will do. Initially, I will create one head like this, like the same way in case of our single linked list. I will create struct struct D-link type of value, that is H. So, H is the head which is going to store the address of the first node. Okay. So, H is the variable, say for example, this is our variable and this is H. Initially, I will assign inside H some value, that is null. So, this value is null. Now what? Now we will write the insert function for this. Those who are getting some problem with understanding this, please go through the single linked list first, then come to double linked list. So, we are here to implement say for example, void ins, our insert function. Here I am trying to insert some variable, that is x is the variable. Now, initially I will create a node like this, I will allocate some such type of place. So, I will have some variable, I will use this data type. So, data type name is struct struct D link. I will calculate the size using size of, then I will pass the whole value through a function, the function name is malloc. Then I will typecast the value, why it is required to typecast, go through the typecast video. Okay. Then I will have struct struct link and here is the pointer, and I will store, say for example, a variable name is k, and k will be of struct struct s link pointer k. So, only here h is the global variables and other variables are local to the block, local to that function. So, when the function will execute it or function will finish its execution, then this variable will be destroyed. Now, here what we will do first, I will assign the value. So, k arrow value, this is our value part. Say for example, I have assigned some memory, like this is our memory, that we have allocated. So, we have allocated this memory, say for example, its base address is 7000. So, this is k, which is stores the base address of this location and it is there. So, k arrow value part, this is the value part, I am going to store this x whatever value I am getting from the user, then that value will be stored here. Then k arrow L address and k arrow write address, both will be assigned as null. So, this is the initial case. So, I am assigning this as null and this also as a null. So, both the places are allocated as null. Now, what? Now, think about the scenario like the same way in case of our in case of our single linked list, we have like this is our head, this is having 7000 and it is pointing some memory and having double link. How the double link is created? By help of those values, these are the double. Okay. So, this is, say for example, 7000, this is 9000, this is 3000. So, what is the thing here? This is null, this is 9000, this is 7000, this is 3000, this is 9000. So, both of them are linking, this is 9000 and some values like 10, 20, 40, these are the some random values, they are stored. Now, what? Now, we are trying to insert a new value, like this is my k now, I have created a new address at this location, location is 5000 is the base address. So, k is holding the base address, like k is holding what value? 5000 base address of this place. So, this is our k. So, k is declared. So, K is declared here, K is allocating some new memory space. I am assigning K arrow value equal X, K arrow left address and right address both are assigned as null. So, K arrow this value is assigned with the X and this is null and this is null again. Now, what is our goal now? Our goal is now what? Our goal is now what? I have to find where I want to assign. My goal is to this 5000 must be here, this 5000 must be here and this null must be what? This must be 3000. So, by this way I can able to create a link between this and this. Okay. So, this is the target hour. So, how we need two things, one is 3000 and another one is 5000. By 5000 I can able to access this one. I have the K, yes, and now I need this 3000. Now, how I will able to get 3000? So, I will copy. I am declaring some variable m, I am copying head. So, m is now, this is our m is having what value? M is having, so this is our m, say for example, this is our m having the same value, that is the 7000. Now, what? We will just traverse while m arrow address. So, this is not address, this is which address we are trying to take? The right address, RA not equal to null. So, m arrow right address, m is what? 7000, arrow right address means 7000 arrow right address means this one 9000. Is it null? No. So, I will move m equal m arrow right address. So, right address is this, right address is this one. So, this value will be assigned here. So, m is now 9000. So, m is pointing now this location. Then what? I will again reiterate this loop. Again I will check m arrow right address 9000 arrow right address, is it null? No, it is not null, it is 3000. So, I will again come here. I will again come here. Again I will check. I have just assigned that m equal m arrow right address. M arrow right address is 3000. So, this value will be deleted or replaced with the 3000 value. Now, this value is 3000. This is pointing now this value. So, m arrow right address, yes, it was null, it was null, it was null, or it is null now. So, what will happen? We will come out this loop and what is required? So, m is holding 3000. So, I need what position? This position. This position is m arrow right address. 3000. This position is 3000 arrow right address. This position is 3000 arrow right address. So, 3000 arrow right address. So, 3000 is m. So, outside of this m arrow right address, m arrow right address is assigned by what value? I will assign 5000 here. 5000 is stored where? Inside K. So, this value will be stored. And this position left address, whose left address? K arrow left address will be assigned by 3000. 3000 is what? M. By this way we will able to insert all the values in the double linked list. In case of display is so simple. So, in case of void display, so whenever we are trying to display again, so first we will check whether this head is null or not. If it is null, if head equal null, I will say printf empty. Now, in else case what? I will copy the head and again traverse through the list. So, I will copy the head. So, as we can again use m because m is the local to the block. So, we can use m. So, here one thing is required, here we need to declare m. Okay. So, here we have copied m, again while m arrow right address equal not equal to null, we will keep printing printf %d comma this value m arrow val part, this value will be there, and we will move every time move m equal m arrow right address, okay, m arrow right address. Just take a pen and paper with you always whenever you are trying to understand these concepts or you are trying to implement these concepts. Always try to make a pen and paper with you, and at the same time try to design the memory map like this way and try to understand each and every line by writing, then only you can able to understand the concept. Okay. So, this is the case, but what will happen? What will happen in this case? Can you tell me? Yes, the last value. What about this last value? Because when m arrow address, the right address is null, so this value is not printed. So still m having 5000 value. So what we will do? At last outside of this while loop, we will just print printf %d m arrow val. So by this way we can able to implement the insert and display function for double linked list. So this is the implementation of double linked list. Okay. Thank you for watching. If you have any query, please write in the comment section.